Alright guys, so for today we are going to be learning on linear motion 2. This time it's the second subtopic of the second chapter. It's going to be the uniformly accelerated motion. Alright, this chapter, there's a couple of things that you guys need to know. Number one, formulas are always the same that we're going to use. We're going to be looking at these 4 formulas every single time. Number two, calculations vary atau berbeza untuk situasi berbeza. Kalau setiap value kat sini anda letak salah, maka jawapan akan jadi salah. Itu nombor 1. Nombor 2, benda ni semua kan vector quantity. Velocity, acceleration semua kan vector quantity. So the moment you put it wrongly, negative sign, kalau tiada sometimes, then it's going to go wrong. Okay? Just a moment. So it's going to go wrong. Alright? Okay. So now, let's move on to uniformly accelerated motion. So there's a couple of symbols that you guys need to know. Number 1, V indicates final velocity, U indicates initial velocity, A acceleration, T time, S displacement. Okay, S ni boleh juga jadi distance. When they ask to calculate distance, maksudnya gunalah S ni sebagai distance. The moment you use S as a distance, you should calculate it in scalar quantity. No more calculating in vector quantity. Kenapa? Distance adalah scalar quantity. Okay, these are the symbols that you guys need to know. Now, formulas. There's 4 formulas and all 4 ni selalu akan digunakan. Okay, now, first one is V equals to U plus AT. Second one is S equals to 1 over 2 U plus VT. Remember your brackets. Third one, S equals to UT plus 1 over 2 AT square. And finally, V square equals to U square plus 2AS. Alright, itu nombor 1. Yang kedua, formula ni, if you realize, yang ini kan dua-dua subjek dia S. So, you can also write 1 over 2 U plus B T equals to UT plus 1 over 2 AT square. Sebab dua-dua equals to S. Okay. Tapi, untuk S ni, dia depends on situation. Sometimes this S, kalau both the S is in one situation atau dalam satu soalan yang sama, then you can use it. Kalau it's in different situation, you can't keep on using S equals to S. Okay? But remember, this one is equals to this one. Kenapa? It still represents displacement. Okay? Alright, that is number 1. Number 2, kalau V equals to UAT or whatsoever, kalau dia cakap at constant velocity kan sebelum ni kita dah belajar. The moment they talk about constant velocity, ada tak acceleration? No acceleration. Okay? When the moment there's no acceleration, kamu 0. Okay. Tak payah duk susah-susah fikir apa value T. Kenapa? 0 darab dengan apa-apa value kat sini pun akan jadi 0. So automatically write 0 darab T equals to 0. Don't forget to write the 0 tau. Ganti the acceleration with 0. Okay? Because you might get, sometimes you'll just like leave out the AT. No matter what dia kosong ke lepas tu, tak ada value apa-apa, tulis juga O darab T. Okay? It's part of your working solution. Alright, now, without further ado, I'll explain how to use these kind of formulas in questions. Alright, let's go to the first question. Okay, now, the first question says, let's have a look. Okay, before we move on to the question, I would like to remind you guys, sekarang zaman ni tiada sudah AB like this, A, B, C, D, consequent questions. Nowadays, they'll just give you one long question, jawablah anda. Marks can be 7 to 10 marks pun boleh untuk satu soalan. So you must know what to do with the question the moment you get it. Now for this case, we are going to look at whatever you guys can imagine. Untuk 2.2 ni, you guys have to really imagine very well how the situation goes walaupun they direct. 2.3 nanti, projectile motion, we are going to learn on how it goes up at an angle and so on. How it goes down with the help of gravity and so on. Okay, in this 2.2, you guys are going to imagine properly how does everything work in reality. Alright, now let's have a look at this question. First question says, a plane, okay, you must know how does a plane move. Okay, that's very important. Lands on a runway. Maksud dia tengah landing or taking off. A plane lands on a runway. If you're not sure about it, right, don't worry. Have a look at the question first. A plane lands on a runway at velocity 50 meter per second and decelerates at constant rate. Kalau dia nak jadi pelan, confirm dia kena landing kan, because it's going to stop after that. That is the logic behind this first sentence. Okay, so a plane tries to land on a runway at a velocity 50 meter per second. Values are very important. Decelerate also equals to negative acceleration at constant rate. Remember, acceleration at constant rate. Alright? Next, deceleration at constant rate. Okay. The plane travels 1.0 kilometer before stops. Maksudnya sebelum, the plane is still moving, but it's going to stop. But it's decelerating at a constant rate at the same time. Lepas traveling 1 kilometer, baru dia completely stop. Okay? Okay, now, before you do anything, write down this. Stuva. Apa ni stuva? Stuva is whatever you guys have seen here. See, everything here is thing. Alright, you guys write stuva. Okay, number 1. Fill up dulu stuva sebelum buat calculation. First things first. What is S over here? S over here is 1.0 kilometer. Kenapa? Displacement. You can also talk about distance, tapi S over here is displacement. Terang-terang dekat sini dah tulis the plane travels 1.0 kilometer. Tapi in physics, you can't be writing 1.0 kilometer. Always remember physics change it to SI units. SI units untuk distance atau length is meter, right? So 1000 meter. That's number 1. Number 2, time. Anything here about time? No. Tak ada apa pun pasal time. So which means you have to find it. Okay? Don't worry. Kalau you tak tahu nak cari macam mana, we have a look at the questions. We are only looking at the situation dulu. Now, initial velocity. Sekarang, we are talking about the plane still flying. Tapi, the plane wants to land. Maksud dia, lepas plane to land and stop, that is final velocity. And when the plane is still flying and trying to land itself to the runway atau cuba nak landing, itu initial velocity. Final, masa dia stop. Tengok sini. Final, masa dia stop. Initial, nak cari kat mana? Tu soalan dah bagi. Plane lands at velocity 50 meter per second. Therefore, the initial velocity is 50 meter per second. Atau you can also write 50 ms negative 1. Itu initial. Final, stops. The moment stop, put it out. 0 meter per second. Okay, don't confuse yourself. Stop, okay. Just because it stops, decelerate at a constant rate is going to be a different value. No. Ada perkataan terang-terang stop, just write 0 meter per second. Alright now. Acceleration. Dia cakap sini deceleration. You also know negative acceleration. Maksudnya jawapan dia akan jadi negatif sini. Tapi ada tak value? Tiada. Okay? Now, these are the values that you know. Let's have a look at the first question. Deceleration of the plane. Maksudnya dia suruh cari yang ini kan? But you know the answer will definitely be negative because we're talking about decelerating. Okay. What I recommend you guys to do, tulis balik all this formula again. So, what you'll have? Number 1, V equals to U plus AT, S equals to 1 over 2 U plus VT. You'll have S equals to UT plus 1 over 2 AT square and V square equals to U square plus 2AS. Okay, that is the second step. Now, what do you have to do? You nak cari A kan? Okay, nak cari A, cara paling senang is to compare your stuva with whatever formulas we have here. Now, let's have a look one by one. V, okay, sudah ada. U, okay, sudah ada. A, kena cari. A yang kena cari. T, ada tak T? Tiada juga. So when you have two unknowns, how are you going to find it? You nak cari satu value je. So cross out this formula. Next, S, ada. 1 over 2 is a value. U ada, V ada. T, tiada. You can find T, tapi kenapa jalan panjang? Sebab you boleh find T dulu. Tapi dia punya soalan tanya deceleration. Deceleration dia nak A. Okay. Tapi bear in mind atau ingat, benda ni bukan tak boleh guna, tapi it will take you some time to find A. Nak cari T dulu, lepas tu cari A. So, let's have a shorter method. Let's have a look at the next formula. S, ada. U ada. T tiada. 1 over 2 value ada. A kena cari. T pun kena cari. Definitely tak boleh. Kenapa? Dua unknown. Next, V ada, U ada, 2 value, acceleration kena cari, displacement ada. So this is the formula that you're going to use. The simplest and shortest formula. Don't memanjangkan keadaan. Kenapa? Sometimes you'll get so confused. Kadang-kadang situation, yes, it's about the plane, but then sometimes there will be a couple of situation going on. Soalan dia takkan jadi dua sentence like this, you know. Questions will be like 3, 4, 5 sentences. Quite long. And it'll give you like 7 to 10 marks for one question. You gotta answer. There's no A, B, C, D. Satu soalan je. So you have to do step by step. So find the shortest way for you to get the answer step by step. So now, let's have a try with this question. V square equals to U square plus 2AS. So V square kosong. Okay, dekat sini tak payah tulis unit pun tak apa. Okay, you guys don't want to write units pun tak apa. Next, initial 50 square plus 2A you need to find. S, remember, tukar pergi SI unit, 1000. So you will get your answer of A is negative 1.25 meter per second square. Don't forget negative, don't forget unit. Tiada salah satu, confirm salah jawapan. Alright, that is number 1. Number 2, if you guys want to write the answers in this form, the deceleration of the plane is, dekat sini ada deceleration. Deceleration already membawa maksud negatif. So you can definitely automatically write 1.25 meter per second square. Alright, there's 2 methods for you to write. Yang ini atau yang ini. It's best for you to write the second one. Kenapa? Dia tanya deceleration, not acceleration. Alright, A is for acceleration. So you have to write back the sentence. This is the deceleration of the plane is buang negatif. Kenapa? Negative is deceleration. Just write the value. Jangan lupa unit. Alright, that is for A. Now let me erase a little bit. Alright, that is A. Alright, so if there's no questions, let's move on. B, the question asks the time taken for the plane to stop. Okay, maksud dia tanya sekarang apa? T kan? Terang-terang dekat sini T. So you have to find the time taken for the plane to stop. Alright? Now, tadi S dah ada, U dah ada, V dah ada, A. What was the value just now? 1.25 kan meter per second. Okay. Dalam soalan ni, situasi dia masih sama. Maksud dia, we are still talking about the same plane landing at the same time. Same plane moving at the same velocity. Same plane moving at the same deceleration. And same plane moving 1 kilometer before it stops. Alright? Okay. So now, the time taken for the plane to stop. Okay. As I said earlier, just have a look at the formulas again. You can have a look at the formulas again. V, actually you can use any of these formulas. Why? You ada 1, 2, 3, 4 sudah. You have to find satu je lagi. So you can use any of it. Paling senang I'll recommend is V equals to U plus 80. So to use V equals to U plus 80, your V will be 0, U will be 50 plus A negative 1.25. Jangan lupa negative Y, acceleration is a vector quantity. And then T. So your T will be 40 seconds. Alright? This will be your answers. Don't forget your units. Alright guys, any questions before we move on to the next example?
No.
Alright, thank you. Okay, let's move on to the next question. Okay. This question will be a little bit tricky, but it's okay. Let's have a go. Let's read the question first. A bus, okay, we're talking about a bus now. You have to imagine how does a bus travel. Traveling steadily at 30 meters per second. Okay. It travels steadily at 30 meters per second. Steadily means how? Basically, you're talking about constantly juga kan? So when you're talking about constantly, ini unit kepada velocity. When this is the unit for velocity, constant velocity means what? No acceleration atau 0 for the value of acceleration. Alright? Now, a bus traveling steadily at 30 meters per second along a straight road passes a stationary car. Sekarang ada kereta pula. So we are talking about a bus and a car. Bus, just now you know, no acceleration and 30 meter per second for velocity. Car, we are talking about, it is stationary, but 5 seconds later, it begins to move, okay, with a uniform acceleration of 2 meter per second square. All right, so you guys have to take note over here. 5 seconds later, baru car mula bergerak. But it also moves in a uniform acceleration of 2 meter per second square. Don't get confused uniform velocity and uniform acceleration. When we are talking about uniform velocity, which literally means zero acceleration. But when we are talking about uniform acceleration, which means there's a value for the acceleration itself. It's just that the graph is constant at a certain value. Alright? Now, in the same direction. Bila dia cakap same direction, don't worry, just assume everything is positive. Kalau dia cakap different direction, that is when problem starts to arise. Some will be negative, some will be positive. Alright? Same direction as the bus. Car moves same direction as the bus. Alright, now let's have a look at the first question. Okay, as usual, before we start answering the questions, list out your stuva dulu. Stuva kali ini akan ada dua. Satu untuk bus, satu untuk car. So for the first one, STUVA. Alright, for bus, the displacement, do you know the displacement atau S atau distance? I think it's quite clear that you do not know. Alright? You tak tahu how far it moves. Okay. Next, for the time. We don't know juga. Dia tak bagi tahu apa-apa. Initial velocity for that particular bus movement. Initial velocity, I think you guys are quite clear. It is 30, right? Can I just assume it's 30? Or do you think it's 0? What do you guys think of this situation? Bus to initial velocity dia 30 or 0? Okay, in this case, it's 30. Kenapa? Sebab it's already stated here that the bus is travelling. So, kalau dia tak cakap apa-apa daripada stationary, then it moves 30 meter per second. You can safely write down that the initial velocity of the bus itself is 30 meter per second. Now, final velocity of the bus, you don't know. Next, acceleration of the bus. Acceleration of the bus, over here, also you don't know. Alright, tengok berapa banyak you guys tak tahu dalam sini. Value dia. Next, let's talk about the car. When we are talking about the car, the displacement, you don't know. Time, also you don't know. Initial velocity. Can you guys see over here? Straight road passes a stationary car. Initial velocity kosong. Kenapa? Terang-terang dekat situ, initial velocity kosong. Alright, final velocity. Final velocity, you don't know. Acceleration, 2 meter per second square. Kenapa? It's already written over here, acceleration 2. Remember, this is positive. Alright? Now, don't worry sebab banyak tiada value. Always have a look at the question. Go to the question kalau you guys risau sangat that you guys might not have enough information. Now, let's have a look at question A. Question A states the time taken for the car to acquire same velocity as the bus. Okay, let's take a moment. Dia cakap apa? Car dengan bus akan jadi same velocity. Now, to make your life simple, remember, always kalau ada dua objek like this, just write, let's say yang ini untuk velocity kan? Velocity bus. Velocity car, to make your lives easier. Now, they are talking about acquire same velocity of the bus. Car dengan bus sama, tapi kat sini you don't know initial atau final. Logically speaking, car tidak akan sebab dia dah terang-terang cakap car adalah kosong. Stationary. So dia akan jadi final. That's why I can easily write VC, final velocity of car, will be equals to final velocity of bus. Kenapa? Car has to be same velocity as the bus. Now, formula apa nak guna? Alright. Let's write here formula yang paling asas. Okay? This is the simplest formula that you guys can always use. Selalunya case memang rujuk this formula dulu. Sebelum you guys rujuk whatever formula is down here. Alright? Okay. Now, VC equals to VB. Final velocity over here, we are talking about final velocity of the car, right? Okay. When we are talking about final velocity of the car, you guys don't know the value, right? Tapi, in this case, I can safely assume the final velocity of the car will be 30. Kenapa 30? Do you guys realize here? A bus traveling steadily at 30 meter per second. Bus initial sampai ke sudah 30. Jadi, car initial kosong. Dia nak sampai mana? 30 lah. That's why I said this kind of questions you guys have to pay attention to details. So, final velocity of the car will be 30. Now, what is the formula of V? Let's have a try with this formula. V equals to U plus AT. So when V equals to U plus AT, what is your initial velocity here? Initial velocity sini, kosong. Sudah ada. Plus A, acceleration, 2. Sudah diberi dekat sini, 2. T is the one you need to find. Okay? So, if you use your calculator, you calculate it. You'll get your T 15 seconds. Tapi, please don't forget, time untuk car. So, you have to write TC. Or you can rewrite here, time taken for car is equals to 15 seconds. Alright guys? Do you guys have any questions before we move on to B? This part is, you guys are supposed to understand it properly. Any questions?
Ya, CJ, bolehkah kalau ulang yang kenapa V itu untuk car boleh jadi 30?
Okay, sure. Alright, let me use another colored pen. Okay, kat sini kan, let me erase sikit dekat sini. Sorry. Alright. Dekat sini kan soalan, dia dah terang-terang cakap, a bus travelling steadily at 30 meter per second along a straight road. Okay, itu bus. Sekarang let's have a look at the car. Car mula stationary. Lepas tu uniform acceleration. Tapi remember in the same direction of the bus. Okay. You guys can imagine kan when a bus moves steadily at 30 meter per second. Maksudnya it keeps on moving 30 meter per second. Dari mula sampai ke sudah 30 meter per second. Tapi untuk car dari mula kosong. Final berapa you guys tak tahu. Okay. Sekarang, the word steadily over here means you guys can safely assume that initial velocity and final velocity is still 30. Kenapa? Dia tak cakap apa-apa pasal the bus stopping. Because in the question, they say the time taken for the car to acquire the same velocity as the bus. Not the time taken for the bus to acquire the same velocity as the car. Now, do you get it?
Yeah.
Alright, okay. Now, let's move on to case number 2 or question B. Alright, erase here. Let's try question B. B, the distance travel, distance apa? S kan sekarang dia dah jadi scalar quantity. No more vector quantity, okay? Tapi jangan risau sebab dua-dua same direction. So, it wouldn't matter much, alright? Distance travel by the car when it is level with the bus. Tadi dia cakap apa? To acquire same velocity. Tapi logically thinking kan, walaupun same velocity, bus lebih berat daripada car. So, at times, car will move more distance or further than the bus itself. Tapi tak apa, let's have a look at the question. The distance travel. Tadi, you guys know the SUVA. The SUVA. Let's rewrite. You guys have to rewrite tau. Setiap kali dapat soalan like this baru-baru, you guys just do a table, mini table macam ni. Let's write bus, car. Okay. Now, let's have a look at the displacement. Okay. Displacement adalah the part that you actually need to find. Okay. Tadi kan, we have talked about acquiring same velocity. Sebab itu kita buat velocity untuk car equals to velocity of the bus. Sekarang, we are talking about distance. Tapi, level tu maksudnya apa? Sama. So, I can simply safely assume S atau displacement untuk car is same as displacement untuk bus. Okay, S equals to S, right? Have a look at the formula again. Boleh tak guna ni equals to ni? Atau you can even use this formula equals to this formula. Tapi value berbeza. That's all. Now, let's move on to this question. Time. Time taken for the same velocity. Tadi, time taken for the same velocity. Sekarang, you don't know what is the time taken when the bus will be at the same position side by side dengan car. So, I would suggest you guys assume time untuk bus is T. Boleh guna X juga lah, whatever alphabet. But kalau time, just maintain time dengan T. Now, itu untuk bus. Untuk car, it's not T juga tau. It's not T juga. Kenapa? Dia cakap bus travelling steadily 30 meter per second along a straight road passes a stationary car which 5 seconds later begins to move. The moment it is 5 seconds later, 10 seconds later, maksud dia total time which is T tolak 5. Baru logik. Kalau sini later, kalau before, T plus 5. Now, let me explain this part again. Please pay attention. Sini untuk bus is travelling the whole journey. So you can safely assume time as T atau X atau unknown. Untuk car, you guys know, the car only moves 5 seconds later. So, you have to write the whole journey tolak 5 saat. Baru dia logic. Alright? Next. Initial velocity untuk car. Untuk car, kosong. Untuk bus, 30. Final velocity untuk bus, 30. Kenapa? It is still travelling. Kalau dia cakap, when it is level with the bus, then the bus stops, baru final velocity kosong. Yang ini, terang-terang bus itu travel steadily, then the bus keeps on travelling, but the car is accelerating so that dia side by side dengan bus. So that's why I maintain initial and final 30. Untuk car punya final velocity. Okay, in this situation, do you know what is the car's final velocity? The final velocity of the car you do not know. Okay, you do not know what's the final velocity of the car. Tapi you know the acceleration of the car. So it's 2 over here. For bus, what is the acceleration for the bus? You don't know. Okay, you don't know. Alright, now we have all the details over here. Nampak sikit tapi sangat berguna. Kenapa? Let's have a try with the formulas. Now, you guys know tadi kita dah buat S atau displacement untuk car is equals to displacement untuk bus. Because dia cakap bus dengan car kena be side by side. But they want to find both about the distance. Now, displacement untuk car. You can use S equals to, let's say, UT plus 1 over 2 AT square. Kenapa? S equals to UT plus 1 over 2 AT square. Equals to, untuk bus, okay, I can also use UT plus 1 over 2 AT square. Ingat, walaupun sama formula, value berbeza. Alright now, something we are missing right here. What is it? Alright, please focus guys. Dekat sini, dia cakap bus travelling steadily at 30 meter per second. Maksud dia constant velocity. Maksud dia zero acceleration. Value for acceleration is 0. Automatically substitute over here acceleration 0. Alright, now you can solve it. Jangan lupa belah kiri untuk car, belah kanan untuk bus. Now let's start solving this question ya. Initial kosong. Time, no matter what, akan jadi kosong. Tambah 1 over 2. Acceleration 2. Time T minus 5 square equals to initial is initial untuk bus apa? 30. Tapi time anda kena cari plus 1/2 acceleration kosong tambah darab t square. No matter what, it will still be 0. But please write down your 0 over here, okay? So what it will become? You will continue yang ini, buat yang ini, and then buat yang ini. Kenapa? Sebab yang ini akan jadi kosong, yang ini juga akan jadi kosong. Do basic mathematics, you will get your t value, which is 39.4 seconds. Alright guys. 39.4 seconds ni adalah t kan? T dekat sini. Alright? T dekat sini. Yang ini jangan lupa. T tolak 5. Alright? Kalau ditanya what is the time for car, you have to 39.4 seconds minus 5. Alright. Itu bukan final answer. Dia tanya apa? What is the distance traveled by the car when it's level with the bus? Okay. Part ni tricky sikit. Okay? So, what is the thing that you're going to use? Let me erase sikit sini. Alright. The formula or whatever, you guys want to find S kan? Alright, let's continue. S equals to ut plus 1/2 at square. Dia cakap apa? Distance traveled by the car when it is level with the bus. Distance traveled by the car, displacement of car, when it is level with the bus. Maksud dia, you nak cari displacement untuk car, you have to use values ni semua kan untuk bus. Baru dia akan jadi level. That is physics. Okay? It's not kalau nak cari untuk car, belah sini pun car. No. Because the question clearly states distance traveled by the car when it is level with the bus. So, you have to use initial velocity darab dengan time 39.4 plus 1/2 acceleration 0 t square no matter what, because darab kan akan jadi kosong. So you get displacement of car atau distance traveled by the car equals to 1183 meter. Alright, let me just repeat this part, okay? Distance traveled by the car when it is level with the bus. Okay, the bus is actually traveling the whole journey, okay? But right now, you want to find the distance traveled by the car. Maksudnya the bus is still traveling. Basically, the car has to catch up with the bus in order to be level. So, your distance atau displacement of the car is equals to displacement of the bus. That is very clear. So, if you guys realize, awal lagi kita dah buat yang ini kan? So, ini untuk apa? Cari time. Lepas tu, same concept apply here untuk cari apa? Distance traveled by the car. Alright guys, do you guys understand this part? Any question please ask. No question. Okay, you guys clear? Kalau if you guys have any questions, you guys can ask. Because these kind of situations won't be super direct. That's number one. Number two, soalan tak akan jadi macam ni tau, A, B. Soalan maybe dia akan tanya part B je. Lepas tu you have to know what to do. Need to find time dulu. Lepas tu need to find distance, need to find displacement and so on. Tapi don't worry, I'll be giving out questions for you guys to try. You guys try to dapat the answer. Don't worry, just pass it up. I'll try marking. Okay?